Hi, this is Abhimanyu, and I was presented with the problem to train a document classification model and to deploy it to a public cloud platform, choosing between AWS, Google, Azure, and Heroku. But because Heavywater uses AWS, I went with AWS, and I implemented a document classification model using SVM, that is Simple Vector Machine, and went ahead and implemented and pushed it to an AWS Lambda, deployed it over there, and that led to a creation of a web service and a web page which is hosted on S3, where we can put in our input and see the results. So I'm just gonna walk you through the whole thing, and the code has already been run everywhere and the model has been deployed. So I'm just gonna walk you through the code for now. So starting with the document classification model, here is the code for the document classification model where I used uh, the test case that was presented to me in order to train the model. I started with using multinomial naive Bayes, but then I eventually moved on to SVM following the various rules, various blogs on the internet that says that SVM performs better than the SGD classifier performs better than the naive Bayes for document classification, specifically words classification. So I went ahead and trained a model, split it 80% for training and 20% for test purposes. And I started by creating a pipeline, as you can see, and a TF-IDF vectorizer and a transformer for the both of the classifiers that have been done here. I eventually went with the SGD classifier, as you can see over here, and I ran it and I used the pickle module to push them over to S3, and then we can later use them, pull them down from S3, unpickle them, and use that in our web service. So the results are over here. You can see it has an accuracy of 81%, and it also shows the precision recall and F1 scores for all the different document types that were in the test file that was provided to me. Along with this, for using an API, I used the Flask module with Python, and I created like a small API for it. And here are the bucket name, here are the initial variables that are needed to push it, and we're using these methods to load the model from the S3 bucket, and then we had to create one more pickle dump for the transformer. So I used the TFD model as you saw in the last code, and used like the unpickling it from S3 and then using it over here. So this basically prints out the prediction value, but as the task statement said, that it would be better to get probabilities too, and I know that we can use a simple function which is called predict uh, proba, but because of my time constraints within this week for my work, I wasn't able to implement that, but I'm gonna make that update soon, I guess. But for this time, it isn't there, and it just like shows the prediction for your test case. This is the Flask API, and it uses different modules in here. As you can see, we have the vectorizer and everything in here. Now, moving on to how to upload it on AWS Lambda, which I used to deploy it as a web service. I used Boto and Zappa for that. As you can see, Boto is here. So we used the Zappa module, and there were a lot of problems using Zappa because I had to like downgrade to pip, or like pip versions, going from 18 to point 9 point something, because some of the modules were not compatible over here. But as you can see, I did the deployment, and with a basic you can do like a Zappa init, and you can see the commands over here. Let me just pull it up real quick. Zappa settings for we call our API Y, and it's inside this directory called heavy, and we have set up everything. This is the S3 bucket name, which is called heavy test, and the AWS region, which we used. And slim handler basically is used to like make the whole process quicker. So as you know, it has been deployed. So, and then what initial testing, we can use the http post command from our terminal right here. And I had a trial, like a test file created called payload.json, and it's gonna basically run it. So here we see that the test case ran successfully and it has given us the prediction. It's called reinstatement notice. So the next task was to show it on a web page, a nice looking web page. I'm not too good with front end, so I just did like the minimal thing that I could do and created this, hosted this on S3. And we have the input and a box, text box over here where we can input JSON. We just have to click on submit and it does everything that we just saw running on the terminal. So making it really quick, I'll just pull down the JSON file, copy it, and we go back to the API and we just paste it over here and submit it. And as we click submit, we just wait for it to process, and here goes our prediction for the test case. The accuracy levels, and I know that was like a bonus, and as I already mentioned, that could be done easily with the prediction proba function call in, but because of my time constraints I wasn't able to do that. But I do know about that, and as you can see here, I'm very familiar with the printing the accuracies and the classification reports for all of it. With the nav bars, I got around 71 to 72% of accuracy, but with SGD we really pushed it to like 81. So here's my submission, and I'll be providing the links for the code to my like Git and my all the other links to this hosted website. And I guess I have covered everything over here. The web service works. The model is as accurate here as yours. I don't really know how your model performs. I think that it's understandable, readable, and deployable to anyone. And I've been using like good commenting and everything. It does use the modern packages out there for open source Python programming. I tried to explain everything in the demo, but if I'm not able, like if I miss something, I can do that for sure. But and I was able to run the test case against the web service, and always when you have the link, you can always test your test cases, your custom made test cases over here, and just click on submit, and that gives you the output. So here's my demo for the video, and I know the UI doesn't look so much fancy because my background hasn't been in front end and I'm not so versed with it. As you say, I'm more of a back end kind of guy, and I've been doing Python and data science, and I have like now we can say around 2 years of experience with that. I guess it can be improved a lot the way it looks for sure, but yeah, that's it for now for 1 week, I guess, and that's it. Thank you.